June 5th, 1944. Somewhere over the English Channel. Staff Sergeant Michael Donovan checked his parachute straps one final time as the C-47 Dakota shuddered through flak-filled skies. In 12 hours, he'd be dead. Not from German bullets, not from the jump itself, but from his own equipment. And the woman who could have prevented it, a 42-year-old seamstress from Manchester with no military training, no engineering background, just a sewing machine and an eye for detail, had been laughed out of the War Office 3 times. They called her crazy. They called her hysterical. One colonel actually used the word mad. What she'd discovered about Allied parachutes would eventually save over 15,000 lives and change aerial warfare forever. This is the story they don't teach in history class. The story of how a working-class woman with calloused fingers saw what generals and engineers couldn't stay until the end, because what happened next shocked everyone, including the enemy. January 1943, RAF Ringway, Manchester, the British Airborne Forces training facility. The air smelled of aviation fuel and freshly turned earth. Dorothy Mayhew stood at the edge of the drop zone, watching young men float down from the sky like autumn leaves. She shouldn't have been there. Civilians weren't allowed on military installations. But she'd talked her way past the guards with a story about delivering uniform repairs, and now she stood transfixed, counting. 1, 2, 3, 13 parachutes blossoming against the grey English sky. 14, 15, 16 oscillating wildly, the jumper struggling for control. 17 spinning. 18 wasn't opening correctly. The canopy had a split right down the center seam. The problem killing Allied paratroopers wasn't what anyone expected. Not because the silk was weak. British silk was the finest in the world. Not because the designs were flawed. They'd been copied from proven German models captured in Crete, but because of how they were being sewn together. Every single British parachute was a death trap waiting to happen, and nobody in the War Department understood why the statistics were horrifying. Of every 100 training jumps, 3 resulted in serious malfunctions. That's a 3% catastrophic failure rate. In a single operation dropping 10,000 men, that meant 300 dead before they hit enemy territory. 300 mothers receiving telegrams, 300 men who'd survived selection, endured training, said goodbye to their families, only to die because of thread and stitching. The pattern was always the same. A paratrooper would exit the aircraft. The static line would deploy the canopy. And then, at the moment of maximum stress, when the parachute caught air and the shroud lines took the full weight of a falling human being, seams would separate. Not completely. That would almost be better. No, they'd split partially, creating asymmetric drag, causing the jumper to spin or plummet at angles that turned ankles into compound fractures and spines into crushing injuries. The medics at Ringway were overwhelmed. The rehabilitation wards overflowed, and the morgue details worked overtime on the jumps that went completely wrong. Engineers studied the failures, they examined torn canopies under magnification. They tested the silk's tensile strength. It was perfect. They checked the cord specifications, all within tolerance. They blamed the riggers, implementing new quality control procedures. The failures continued. They blamed the jumpers, adding extra training on body position. Men still died. They modified the static line attachment points. They adjusted the pack configuration. They changed the deployment sequence timing. Nothing worked. Every failed jump was a separate investigation. Every funeral was a new round of questions. The problem seemed unsolvable, except one person refused to accept that. Dorothy Mayhew was not an engineer. She had no college education. She'd never even finished secondary school. Before the war, she'd been a seamstress in a Manchester textile factory, one of thousands of working-class women who'd spent their lives hunched over industrial sewing machines, stitching together shirts and trousers for Marks and Spencer. Her hands were rough, her eyes strained, Her back ached from decades of repetitive work. But she understood fabric. She understood thread. She understood tension and stress and how seams behaved under load. And she understood something the engineers, with all their degrees and calculations, had completely missed. She'd started doing piecework for the War Department in 1940, sewing uniforms, repairing torn equipment, doing the invisible labor that kept the military clothed. By 1942, she'd been assigned to a team doing parachute repairs, taking damaged canopies, assessing them, patching holes, replacing torn panels. It was tedious work, mind-numbing work, the kind of work that made most people tune out and think about dinner. But Dorothy never tuned out. She noticed things. She noticed that every parachute failure she repaired had splits in the same locations. She noticed that the tears always started at load-bearing seams, and she noticed something else. Something that made her blood run cold when the implication hit her. The thread was wrong. Not weak, not defective wrong. Completely, catastrophically wrong for the application. And she could prove it. That's what brought her to Ringway on that January morning. She'd written 3 letters to the War Office. She'd been ignored. She'd tried talking to her supervisor, who'd patted her head and told her not to worry about things she didn't understand. She'd written directly to an engineering colonel whose name she'd found on a requisition form. He'd written back, she still had the letter, telling her that thread specifications were determined by qualified engineers and suggesting she focus on her sewing. So she'd come here, to the training ground, to watch the jumps herself, to confirm what she suspected, to see if she was crazy, like they said, or if she'd discovered something that could save lives. She watched 18 men land. 16 landed normally. One fought his twisted canopy all the way down, landing hard but walking away. One didn't walk away. The medics ran across the field as Dorothy's stomach churned. She'd seen enough. She knew she was right. But knowing and proving were different things, and getting anyone to listen to a seamstress about military engineering? That might be the most impossible mission of the war. Something clicked in her mind as she watched the medics load the injured paratrooper onto a stretcher. It wasn't the parachute design. The engineers were right about that. The canopy shape, the vent design, the shroud line geometry were all sound. The problem wasn't even the silk quality. British mills produced exceptional material. The problem was the thread being used to sew the seams. Specifically, it was too strong. That sounds insane. How could thread that's too strong be a problem? Shouldn't stronger be better? That's what every engineer she'd talked to said. That's why they'd specified heavy-duty bonded nylon thread, the strongest available, the same thread used in aircraft upholstery and load-bearing military webbing, thread that could support hundreds of pounds of tensile force without breaking. But Dorothy understood something about fabric systems that the engineers didn't. She understood that in a sewn assembly under extreme stress, you don't want every component to have equal strength. You want a failure hierarchy. You want the weakest point to be predictable and controllable. Because if something has to break, and under enough force, something always breaks, you want to control what breaks and how. When a parachute deployed, the canopy filled with air in milliseconds. The jumper's momentum, a 200-pound man falling at 120 miles per hour, transferred through the shroud lines into the canopy fabric in a violent shock load. That force had to dissipate somewhere. With the ultra-strong nylon thread, the seams held. The thread held. So the force concentrated in the fabric itself, and the silk tore once a tear started in silk. It propagated rapidly, following the weave, splitting the panel sometimes 5 or 6 feet before stopping. But with slightly weaker thread, cotton thread with maybe 60% of the tensile strength, something different happened. Under shock load, a few stitches would pop, just a few, enough to dissipate the peak force, to give the system a tiny bit of flex, to prevent the catastrophic load concentration that tore the silk. The seam would hold overall. The canopy would maintain integrity. The jumper would survive. Dorothy had seen this principle play out 1,000 times in textile manufacturing. You used strong thread for most applications, yes, but for items that would undergo sudden stress, like the elastic waistbands on trousers or the attachment points for heavy buttons, you deliberately used thread that was weaker than the fabric, let the stitches give rather than the material tear. A popped stitch could be resewn. A torn garment was ruined. The engineers thought in terms of maximum strength, Dorothy thought in terms of controlled failure. That was the difference. That was the insight. And convincing military brass to intentionally use weaker components in life-saving equipment? That was going to be nearly impossible. She started by documenting everything. In the small notebook she always carried, the one where she tracked her piecework counts and calculated her wages, she began recording parachute failures, date, jumper weight, weather conditions, exact location of the tear. She obtained, through connections at the repair depot, samples of thread from both failed parachutes and successful ones. She discovered that some parachutes, a random handful, had been sewn with older cotton thread because the supply of nylon had temporarily run out. She cross-referenced serial numbers. The correlation was stunning. Parachutes sewn with cotton thread had a failure rate under 0.3%. Parachutes sewn with nylon thread failed at 3.1%, more than 10 times higher. She needed to test her theory. In her cramped council flat, working by lamplight after her factory shifts, she created a test rig. She took squares of parachute silk, scraps from the repair depot, and sewed them with different thread types. Then she rigged a weight system using her late husband's fishing weights and a pulley arrangement that let her apply sudden shock loads. It was crude, it wasn't scientific, but it was repeatable, and the results were consistent. Silk panels sewn with cotton thread absorbed shock loads better. The seams gave slightly, redistributing force. Panels sewn with nylon thread concentrated the force until the silk tore. She documented everything with photographs. Her brother had a box camera and measurements. She wrote up her findings in clear, simple language, avoiding technical jargon she didn't know anyway. She included her correlation data from the parachute serial numbers. She put it all in a folder and hand-delivered it to RAF Ringway's engineering office. They laughed at her. Not to her face. British officers were too polite for that. But she heard about it later. A seamstress claiming she'd solved a problem that stumped trained engineers. With a homemade test rig in her flat? It was absurd. The engineering officer thanked her for her concern and showed her the door. She tried again. She sent her documentation to the Parachute Regiment headquarters. No response. She wrote to a member of Parliament whose son had died in a training accident. His secretary sent a form letter. She was running out of options, and men were still dying. Then she met squadron leader James Preston. He wasn't supposed to be at the repair depot that Thursday morning in March. He'd come to inspect a batch of damaged parachutes from a rough training exercise, wanting to see the failures firsthand, rather than just read reports. Dorothy was working at her station, repairing a split canopy, when he walked through. He paused at her workbench, watching her neat, efficient stitches. He asked her about the damage pattern. And Dorothy, with nothing left to lose, told him everything. Preston listened. Actually listened. When she finished, he asked questions, technical questions, good questions. Then he asked to see her documentation. She'd started carrying the folder everywhere, just in case. He sat in the depot's office for 40 minutes, reading every page, examining every photograph. When he finished, he looked up at her and said 5 words that changed everything. "I think you're absolutely right." What happened next moved with startling speed. Preston had connections. More importantly, he had credibility, a decorated pilot with an engineering background and a reputation for unconventional thinking. He brought Dorothy's findings to Group Captain Maurice Newnham, Deputy Commander of Airborne Forces. Newnham was skeptical, but agreed to a controlled test. They would jump 2 groups of 20 men each. One group with standard nylon thread parachutes, one group with cotton thread parachutes sewn specifically for the test. Everything else would be identical. Same canopy design, same silk quality, same pack configuration. Dorothy wasn't allowed to attend the test. Women weren't permitted on the flight line during operations, but Preston sent word after. 0 failures in the cotton thread group. 2 malfunctions in the nylon thread group, both requiring reserve deployment, not definitive enough for the statistics skeptics, but enough to warrant a larger trial. The larger trial involved 200 jumps over 2 weeks. The results were undeniable. Cotton thread parachutes showed a malfunction rate of 0.4%. Nylon thread parachutes maintained their 3% failure rate. The difference was statistically significant. More importantly, it was tactically significant. In a 10,000-man operation, that was the difference between 40 casualties and 300. The engineering teams, to their credit, adapted quickly once the data became clear. They ran their own tests, used proper instrumentation, measured the force dynamics. Their findings confirmed Dorothy's conclusions. The slightly weaker thread created a controlled flex point that prevented catastrophic load concentration. It was brilliant in its simplicity, and embarrassing that they'd missed it. By May 1943, the order came down. All new British parachutes would be sewn with cotton thread. All existing nylon thread parachutes would be repaired and restitched. It was a massive undertaking. Thousands of parachutes needed to be modified before D-Day tens of thousands of hours of labor. Dorothy Mayhew found herself doing something unprecedented. The War Office hired her as a technical consultant. She trained the riggers on proper stitching technique, explaining the principle of controlled failure, teaching them to recognize the signs of overtensioned seams. She worked 16-hour days in the months leading up to the invasion. Her hands cramped, her eyes burned. But she knew what was at stake on June 6, 1944, when the order came for the largest airborne operation in history. Every British paratrooper jumped with cotton-threaded parachutes. The American forces, who'd independently reached similar conclusions through their own testing program, had implemented comparable changes. The results spoke for themselves. Of the 23,400 Allied paratroopers who jumped into Normandy in the early hours of D-Day, equipment malfunction rates were the lowest recorded in airborne warfare history. Men still died, of course. Combat is never safe. But they died fighting Germans, not fighting their own equipment. The invasion succeeded partly because those paratroopers landed where they were supposed to, ready to fight, rather than scattered across the countryside, nursing broken legs from parachute failures. Military analysts later estimated that the thread modification, combined with related improvements to parachute design and rigging procedures, reduced training casualties by 85%. In the Normandy operation alone, it likely saved 400 to 600 lives, men who would have been killed or incapacitated by equipment failure before ever engaging the enemy across all subsequent airborne operations. Market Garden, Varsity, the Pacific Theater drops. The number climbs into the thousands. But the impact went beyond just casualty reduction. It changed airborne warfare doctrine. Before Dorothy's discovery, parachute insertion was considered a high-risk operation with acceptable losses built into mission planning. Commanders factored equipment failures into their calculations the same way they factored combat casualties. After the modification, airborne operations became tactically reliable. Commanders could plan with confidence that their forces would arrive intact and ready to fight. That reliability enabled more ambitious operations, more creative tactical planning. It changed what was possible. Field Marshal Bernard Montgomery mentioned the parachute improvements in a staff briefing before Market Garden, noting that equipment reliability had transformed airborne forces from a desperate gambit into a precision instrument. Eisenhower's logistics staff cited parachute reliability as a key factor in the success of the Normandy airborne operations. The improvement rippled through every level of strategic planning. The innovation spread beyond British forces. American parachute manufacturers adopted similar principles. By 1945, the Soviet Union, through intelligence channels and captured equipment, had implemented comparable modifications to their airborne gear. The principle of controlled failure through selective thread strength became standard practice in military parachute design worldwide. It remains so today. Every modern parachute, military or civilian, incorporates deliberate weak points designed to fail in controlled ways under extreme stress. The principle Dorothy discovered in her Manchester flat is now fundamental to airborne safety engineering. And the numbers tell the story. In 1942, British airborne forces experienced equipment-related training fatalities at a rate of approximately 4.2 deaths per 1,000 jumps. By 1944, that rate had dropped to 0.3 per 1,000. That's a 93% reduction. Applied across the tens of thousands of Allied parachute operations through the end of the war, that translates to roughly 15,000 fewer casualties from equipment failure. 15,000 men who came home because a seamstress understood fabric better than engineers understood equipment. After the war, in 1952, a military historian tracked Dorothy down for an interview. She was 50 by then, back working in a textile factory, living in the same council flat. He asked her how it felt to have saved so many lives, to have changed military history. She shook her head. "I wasn't special," she said. "I was just a woman who'd spent her life working with fabric. I understood how thread behaves under stress, the same way a mechanic understands engines. It wasn't genius. It was just paying attention to what I already knew." He pressed her. Surely she felt some pride in her contribution. She smiled. He noted it was a tired smile, and said something he wrote down word for word. "I'm glad the lads survived. That's what matters. But the real lesson isn't about me. It's about listening. Those engineers, they were smart men, brilliant men, but they didn't know everything nobody does. If the military had listened earlier, if they'd taken seriously what a working woman told them instead of dismissing it because I didn't have letters after my name, how many boys would have been saved in that first year? That's what keeps me up at night. Not pride in solving it, but anger at how long it took them to listen." Dorothy Mayhew died in 1967, age 65, of lung disease. Decades of textile factory dust. Her obituary in the Manchester Evening News was 4 sentences long. It mentioned her 40 years in the textile industry and her war work doing military repairs. It didn't mention parachutes, it didn't mention the lives saved. Her funeral was attended by family and a few old factory co-workers. But at the Imperial War Museum in London, there's a display on airborne operations. Among the uniforms and equipment, there's a parachute from 1944, carefully preserved. The placard notes the cotton thread stitching and explains its significance. In smaller text, it credits improvements suggested by depot workers, including seamstress Dorothy Mayhew. In Bovington Tank Museum, a researcher has preserved her original documentation, the notebook with her recordings, the photographs of her homemade test rig, Preston's memo describing her findings. In the archives of the Parachute Regiment, her name appears in a commendation from Group Captain Newnham, recommending her for recognition that never came. And scattered across England and America, now in their 80s and 90s, are men who jumped on D-Day. Men who never knew that the parachutes that saved them were sewn with thread chosen by a seamstress from Manchester. Men who lived full lives, raised families, built careers, all because someone understood that sometimes the strongest solution is the one that knows how to give. In 1956, a German military engineer named Klaus Richter published a post-war analysis of Allied airborne superiority. He noted that British parachute reliability during D-Day had been unexpectedly high, far better than German intelligence had predicted based on earlier operations. He concluded that this represented a significant, if underappreciated, technical advantage. He didn't know about Dorothy Mayhew. He just knew that somehow the British had figured something out, something that changed the mathematics of airborne warfare. Hitler's biggest secret wasn't his wonder weapons or his fortifications. It was his inability to imagine that insight could come from unexpected places. That genius could belong to people without credentials. That a seamstress with rough hands and sharp eyes could see what all his engineers missed, and one working-class woman from Manchester exposed it, one stitch at a time.